Good morning, dear children. So, last class we started a new lesson, chemical reactions. And last class I said you what is the difference between physical change and chemical change, and what is a chemical reaction, and what really happens in a chemical reaction. So, what really happens in a chemical reaction? In a chemical reaction, rearrangement of atoms takes place due to the breaking of old bond and formation of new bond. So that what happens in a chemical reaction. Now that breaking and formation of bond cannot be seen by us. We cannot see. We cannot see them because bond is force of attraction, and the line that we see is imaginary, so we cannot see. Then how to know a chemical reaction has really taken place? So for that, we should know some characteristics of chemical reactions. For example, I'm a living thing. So how can I say that I'm a living thing? How can you say that you are a living thing? How can you say that plant is a living thing? So there are some characteristics of a living thing, and those characteristics even I have, so I'm a living thing. For example, what are the characteristics of a living thing? Living thing grows, living thing responds to stimuli, living things die, living thing reproduce, living thing needs air to live. So these are a few characteristics of a living thing, and I possess all those characteristics. That's why I'm a living thing, that's why you are a living thing. Now for a change, for a reaction, for a change to be chemical change, for a reaction to be chemical reaction, there are some characteristics by which we can come to know that the reaction is a chemical reaction. So these characteristics we are going to learn today, going to know today. So these characteristics, so how to know chemical reaction has taken place? So by knowing these characteristics, we can come to know that a chemical reaction has taken place. Number one, evolution of gas. Some of the chemical reactions are characterized by evolution of gas. For example, if you take sulfuric acid, dilute sulfuric acid in a test tube and add a few zinc granules in that dilute sulfuric acid, you can see bubbles coming up, and these bubbles are gases, and the process, the formation of gas bubbles in a liquid during a chemical reaction is called effervescence. It's called effervescence. Effervescence. So what is effervescence? The formation of gas bubbles in liquid during a chemical reaction is called effervescence. So when you are, for example, when you open this one, Coca-Cola or Pepsi or Thumbs Up bottle, then you can see the bubbles coming up. Without opening also you can see whenever you take out the drink, the soft drink from out of the refrigerator, you can see the bubbles going up. So these bubbles, the formation of these bubbles of gas in liquid is called effervescence. So what happens is, why in that carbon dioxide is dissolved. That's why that carbon dioxide is coming out, and that is not a chemical change. Because initially carbon dioxide was added, and due to the change in temperature and pressure, that carbon dioxide is coming up. So initially it was added, and now again it is coming out. That means that is a physical change, because no new substance is formed. But here what I am talking is, you are taking liquid dilute sulfuric acid. You are taking a liquid that is dilute sulfuric acid. So you are taking dilute sulfuric acid and then zinc plus dilute sulfuric acid zinc is solid and this is dilute, that is liquid. This is liquid. When you put this zinc granules in sulfuric acid, then you will get zinc sulfate plus hydrogen gas. So the gas, the bubble that is coming up is hydrogen gas. Initially there was no gas. And we can get gas. So this evolution of gas, initially we are not adding gas and a new type of gas is coming out. We can check the properties also. That will come to know later. But now we are talking about the characteristics of chemical reaction. So number 1 is evolution of gas. Number 2 is change of color. Some of the chemical reactions are characterized by changing color, formation of precipitates, and some of the chemical reactions we can see insoluble solid will be formed as a precipitate. And some of the chemical reactions are characterized by change of state. In some of the chemical reactions, state will change. State of the matter, state of the substance will change. If you are combining gas and gas, then you are getting solid. There is change in the state. Then change in energy. Energy will also change in a chemical reaction. So knowing these 5 characteristics of a chemical reaction, we can come to know that the reaction that is taking place is a chemical reaction. Now we'll do one by one with example. So first of all is evolution of gas. Evolution of gas. Now, zinc granules. Zinc granules. Granules means powdered zinc. Granules means powdered zinc. This is solid. Plus sulfuric acid. Sulfuric acid. Dilute. Dilute sulfuric acid. This is liquid. When reacts, gives zinc sulfate, which is aqueous, plus hydrogen, which is gas. So when you put zinc granules, powdered zinc, impure zinc, not pure, powdered impure zinc, that means the zinc which contains copper as impurity, that helps in releasing hydrogen gas very efficiently. So zinc granules is solid, and I am adding these zinc granules in sulfuric acid, dilute sulfuric acid, not concentrated. That means sulfuric acid in which portion of water is more than the portion of sulfuric acid. Portion of water is more than the portion of sulfuric acid. So sulfuric acid dilute liquid, if I mix them, then what I will see is that the bubble of gas comes out, which is called effervescence. The formation of bubbles of gas in liquid during a chemical reaction is called effervescence. So effervescence of hydrogen gas. Means hydrogen gas will be formed. And by seeing these bubbles coming up, I can be sure that the chemical reaction has taken place. Because initially I am not adding any of the gas and I am getting gas. If you initially add gas and you are getting gas, means there is no change. So solid, liquid, and then zinc sulfate. I will not see zinc sulfate because zinc sulfate is dissolved in water, aqueous. Zinc sulfate is dissolved in the water present in that sulfuric acid. So zinc sulfate, and then hydrogen gas is involved. So if I have to write chemical equation, this is word equation. If I have to write chemical equation, then it will be like this. Zinc sulfate, which is aqueous, means in water, dissolved in water, plus hydrogen gas. So gas is denoted, represented by upward arrow. So in this way, we can come to know that the chemical reaction has taken place. How can we come to know about that the chemical reaction has taken place? Number one, by the evolution of gas. Whenever you mix something and gas is evolved, then you can be sure that a chemical reaction has taken place. Number one. Now number two. What was number two? What was number two? Number two was change in color. Change in color. Change in color. Some of the chemical reactions are characterized by change in color. Color changes. For example, if I take iron, yes, if I take iron and then I put this iron is in which color? Grayish white color. Iron is grayish white color. Grayish white color iron plus solid plus copper sulfate solution. Copper sulfate solution, which is blue in color. When I combine this, that means first of all take copper sulfate, then add it in water, then you will get copper sulfate solution, and that copper sulfate solution is in blue color, pale blue color, and then you add iron nail or fresh iron, which is grayish white grayish white in color. Then what you see is this will change to FeSO4. The reaction is like this. But you cannot see the reaction taking place. Then how to know chemical reaction has taken place? So what you can observe? You cannot observe this. These are symbols only. You cannot observe. So what you really can observe is, you can observe that first of all the solution was blue in color, but now what you can see is the solution has changed to green in color. The solution has changed to green in color, and you will see at the bottom that copper reddish brown. Okay. So after the reaction, you can see that the blue color solution changes to green color. Blue color solution changes to green color, and there was no reddish brown color at all when I was combining these two. But in the reaction, I can see that reddish brown copper will be settling at the bottom. So there is change in color. So by seeing that there is change in color, I can be sure that the chemical reaction has taken place. Then there are many examples you can go through. Now number 3. What is number 3? Formation of precipitate. Formation of precipitate. Number 3 is formation of precipitate. Before giving example for formation of precipitate, I want to tell you what is precipitate. Precipitate is insoluble solid formed in a reaction. Insoluble solid formed in or during a chemical reaction is called precipitate. Insoluble solid formed during a reaction is called precipitate. Okay. Now let's see this with example. FeSO4. What is this? Iron sulfate. What is this? Iron sulfate. FeSO4 aqueous means solution. Iron sulfate. You take iron sulfate. Had it been in its schooling days, I would have done it in lab. So iron sulfate. Iron sulfate, when you dissolve in water, it becomes iron sulfate solution. It becomes iron sulfate solution. And is it chemical change or physical change when I dissolve? No. Dissolving is a physical change. No new substance is formed. So iron sulfate is there. Then I am adding sodium hydroxide. I am adding what? Sodium hydroxide. Sodium hydroxide. This is also aqueous, that means sodium hydroxide solution. In one test tube, I will be making solution of iron sulfate. In another test tube, I will be making solution of sodium hydroxide. And then I will be mixing these two. I will be mixing these two. Then what I will see? This is also not insoluble. This is soluble in water. This is also not insoluble. This is also soluble in water. So both the solutions are clear. There is no solid at all. Both the solutions are clear. But when I combine these two, what I will see? I will see that now the reaction that is taking, the mechanism, the reaction that is taking place is this: FeOH whole twice plus Na2SO4. This will be the reaction. But what is there is, we don't see the reaction. We cannot see the reaction. Okay? So, something we can observe out of it. We can observe something. So, what we can observe in this is, first of all, iron sulfate was a clear solution, and then sodium hydroxide was also a clear solution. But when I mix these two solutions, then what I'm getting? I'm getting solid. I'm getting solid substance which was not there initially when I was reacting. So I'm getting solid substance. Now how come this solid substance when there was no solid substance in the reactant? So a new substance has been formed. That means it is also a chemical reaction. So the reaction that is taking place is this. But what we observe? We observe that out of these two solutions, I am getting one solid substance which is insoluble, which will be settling at the bottom, and then another is sodium sulfate, which is dissolved in water, which I will not be seeing. But there are many ways to test it. But then also that is testing. Then only I can prove, okay, that is there. But now for this case, what we observed is insoluble solid is formed. And this insoluble solid is called precipitate. This insoluble solid. And mind one thing, in a chemical reaction, precipitate or insoluble solid is represented by downward arrow. Gas is represented by upward arrow, and formation of precipitate is represented by downward arrow. Formation of gas is represented by upward arrow. Formation of precipitate is represented by downward arrow. So this is insoluble solid formed, and what is the color of this? The color of this is white. White precipitate will be dotty green precipitate. Dotty green precipitate will be formed. What kind of PPT, what kind of solid will be formed? Dotty green solid will be formed at the bottom. which was not there. So that means a new substance has been formed. So observing this change, we can be sure that a chemical reaction has taken place. So one of the ways to know a chemical reaction has taken place is by seeing the formation of precipitate. Now there are a few more examples you can go through. Then number 4, how to know a chemical reaction has taken place. Number 4 is change of state. Change of state. Physical state, I mean to say. Physical state. Physical state. In which state river Ganga flows. Yes, you may be saying UP, you may be saying West Bengal, but that is wrong because this is chemistry class. So, here river Ganga flows in liquid state. So, state I am talking about is liquid, solid, liquid, gaseous and aqueous. There are 4 states. Okay, liquid, solid, liquid, gaseous, even aqueous is also liquid only. But what is aqueous? Aqueous is the solution in which water is the solvent. So, aqueous state. Generally, these 4 things we use in while writing chemical equation in chemistry. So, change of state. So, we will see some of the reaction. We can see that there is change of state. For example, H2S. Hydrogen sulfide. What is this? Hydrogen sulfide. This is hydrogen sulfide and this is gas. This is hydrogen sulfide and this is gas. When I mix this with chlorine gas, this is chlorine gas. So when I pass chlorine gas over hydrogen sulfide gas, when I pass chlorine gas over hydrogen sulfide gas, then what will there is hydrogen water reaction takes place is hydrogen chloride and sulfur will be formed. Hydrogen chloride and sulfur will be formed, and this hydrogen chloride is gas and this is solid. Sulfur is solid. So this is hydrogen chloride, and this is sulfur. So, and the color of this is yellow solid substance will be formed. Hydrogen sulfide is pungent. It has a very pungent smell of rotten egg. You know, you are familiar with the smell of rotten egg. If you are familiar with the smell of rotten egg, then it will be easy for you to know about hydrogen sulfide gas. Hydrogen sulfide gas also has the smell, pungent smell like that of rotten egg. So hydrogen sulfide gas, when chlorine gas is passed over hydrogen sulfide gas, we will get hydrogen chloride gas and then sulfur. Now here you can see a gas is combined with a gas. Gas is combining with a gas, and what we are getting? We are getting a solid. We are getting a solid. Gas is combining with gas, and we are getting one of the product as solid. That means there is change of state. And seeing this change in state also, we can be sure that a chemical reaction has taken place. You may be thinking that in a physical change also state changes, but in a physical change what happens is a new substance will not be formed. Now here you can see that this is a hydrogen sulfide gas, is a colorless gas. Chlorine gas, if it has color, then also here you are getting different color solid, that is yellow solid you will be getting, which was not there. But in case of water converting to ice, the color doesn't change. But here it is changing. That means the solid, the change of state is associated with the entirely different properties than that of the reactant. That's why it is a chemical It is a chemical change or chemical reaction. So last one is change of energy. Last one is change of energy. So what happened is in a change in energy. Change in energy. So actual chemical reaction is associated with the change in energy. So what you do is, you are very much familiar with tuna, that in chemistry we say quicklime calcium oxide. Quicklime or calcium oxide. Calcium oxide. This is also called quicklime. Quicklime. So calcium oxide. When you bring this calcium oxide, then generally what we do is for whitewashing of the walls, we just put this calcium oxide solid, this solid calcium oxide in water, which is liquid. So when we add this calcium oxide in water, then what we see is the chemical reaction that is taking place is calcium hydroxide will be formed. What will be formed? Calcium hydroxide will be formed. Let's balance this reaction. Calcium hydroxide will be formed. So calcium hydroxide will be formed, and this is aqueous. Aqueous. That means it will get dissolved in water. But what happens is, when you do this, it starts boiling. If you take cold water, then also it starts boiling. That means whenever you combine these two, then heat is given out. That means it is released. Here heat is released. So heat is given out. In this reaction. You don't dare, but then also if you touch outside the container, then also it is very hot. You can see that the water is boiling. Water will boil. That much heat it has. So it is exothermic reaction. So what is exothermic? This is exothermic reaction. So exo means out. Thermic means heat. So the reaction in which heat is given out is exothermic reaction. That means I can write plus heat. So some of the reactions are there in which heat is released, heat is given out. That means there is change in energy. Initially, I didn't apply heat, but initially when I was mixing these two, it was cold. The mixture was cold, but now the mixture is very, very, very hot. So there is change in energy. And this change in energy is because the reaction is exothermic reaction. The reaction is exothermic reaction because heat is given out. And some of the reactions are endothermic reaction. Endo means in, thermic means heat. That means heat is consumed. For example, decomposition of calcium carbonate. Calcium carbonate gives calcium oxide plus carbon dioxide. So here you have to apply heat. Here you have to give heat. Endothermic. Here you have to give heat. And that's why you will write here minus heat. Heat is given to the reaction. It is given to the reaction. It is not released. Here heat is absorbed. You have to apply heat so that calcium carbonate converts to calcium oxide and carbon dioxide. This much for today. Thank you.